What we're going to do is we're going to look at graphing polynomials. We looked last time at finding the x-intercepts. Now what we're going to do is we're going to continue finding the x-intercepts and then move into graphing it. So before we move into solving the problems, when we're looking at a graph, there are 4 different types of graphs. Our first one has to do with x to the even power. And whenever it's negative, then that means that it's both going down on the left side of the graph and right side. As opposed to an exponent that's even, that's positive, both of them are going to go up. And just as an example, that would be like a quadratic, a quartic, or beyond. Now, the other ones would be odd exponents. So if we have x to the odd exponent, anything to the third, the fifth, the seventh, whenever it is negative, what's going to happen is one goes down, the other one goes up. And then when we have an odd one that's positive, once again, one of them goes down and the other one goes up. So those are our 4 different types of graphs that we're going to be dealing with. Now, for our first one, what we're going to do is we're going to look at factoring this one. And then for the other ones, we're going to be looking at using synthetic division. So we talked last time of the different approaches. The reason that I can factor this one is I see that it's factored by grouping. So I'm going to set it equal to 0. I see that they have a negative 3x squared in common. And then that gives me an x minus 2. And then I have a 12 in common, and that's an x minus 2. I see that they both have an x minus 2 in common. And then we have a negative 3x squared plus 12. If I factor out the negative 3 out of the second binomial, what I end up with is negative 3 x minus 2, and then this one is x squared minus 4. And of course, the x squared minus 4 would be x plus 2 and x minus 2. So when we solve this, we have 2, we have negative 2, and then we have 2 again. There's a significant part of the 2 being twice, so I'm going to write it twice, and I'll come back to that. Now that's the x-intercept. Next thing that we're going to do is we're going to find our y-intercept. How we find our y-intercept is we look at our constant value, and that tells us what our y-intercept is. So in that case, it would be negative 24. Now what we're going to do is we're going to look at our end behavior. How we solve the end behavior is we write as x approaches negative infinity, and then we put as x approaches positive infinity. Now, x approaching negative infinity means what's happening on the left side of the graph. X approaching positive infinity, that means what's happening on the right-hand side of the graph. What we're going to do is we're going to take our leading coefficient and we're going to plug in a negative infinity. When we plug in a negative infinity, I'm just going to treat it as a negative to the third power. I don't care about the actual value, I just care about the direction. So 3 negatives means it's a negative times a negative is a positive. So that means that y approaches positive infinity. And then as x approaches infinity, what we're really saying is as x approaches positive infinity, so if I throw in an infinity in there, it would be 3 positives is a positive times a negative is a negative. So we have y approaches negative infinity. Now what I'm going to do is I'm going to graph it. When I graph it, I'm going to first start off with plotting the x-intercepts. And so I have 2, I have negative 2, and then I have negative 24. I'm going to label the negative 24 so I don't have to put 24 tick marks. Now, with the first one, what it says is as x approaches negative infinity, that means the left side of the graph, it goes to positive infinity, meaning it goes up. As x approaches infinity, y approaches negative infinity, meaning it goes down. And then what we're going to do is we're going to follow the line. It's going to hit the 24. Now, what I want to point out is that for the first one, it goes through the line because we have 1, -2. But for the second one, it's not going to go through it. It's going to hit it, and then it's going to come back down. And the reason why is because it's going through it twice. It goes up through it and then down through it because there's 2 2's. And so that's what our graph looks like. So for this one right here, what we're going to do is we're going to look at synthetic division. First thing I want to do is find all my possibilities. So x equals ±1, ±2, ±3, and ±6. I have 1, -1, -7, 1, and 6. And when I'm looking at trying to figure out one of the values, what I have to do is guess. One thing that I always look at is if I add up all the coefficients, do they equal 0? And in this case, they do. 1 + 1 + 6 is 8. -1 - 7 is 8. So I know that 1 is one of the answers. So I bring down the 1. 1 times 1 is 1. 1 times 0 is 0. 1 times -7 is -7. 1 times -6 is -6. So that's one of the answers. The problem is that it's not factorable. So I have to do this process again. So those are my coefficients. And what I'm going to do is pick another number. I'm going to pick -2. I bring down the 1. -2 times 1 is -2. That's -2. That gives us a 4. -3. That gives us a 6, which is a 0. So this is x squared minus 2x minus 3. And that factors as -3, -2, which is -3, +1. So when we factor it, x minus 3, x plus 1 is equal to 0. And our answers, 3, -1, I have -2, and I have a +1. Now, next thing I'm going to do is I'm going to look for my y-intercept. My y-intercept is always the constant value. So my y is equal to 6. And now I'm going to look at my end behavior as x approaches negative infinity, as x approaches infinity. So when I plug in a negative into the x to the 4th, so a negative to the 4th power would be a positive. So that means that y approaches infinity. When I plug in a positive infinity, infinity to the 4th would be a positive. So that means that y approaches infinity. Now what I'm going to do is I'm going to graph it. And when I graph it, I have 3, I have -1, I have -2, and I have a +1. The y-intercept is at 6, so I plot a point at 6. As it goes to the left, it says that it goes up. As it goes to the right, it says that it also goes up. So now what I'm going to do is I'm going to graph it. So I'm following the lines, and that right there gives me my answer. Okay, letter C. What I'm going to do is I'm going to factor it. So I have a -2x that I take out, and then that's left x squared minus 4. And then that can factor some more as x minus 2 and x plus 2. So my zeros are 0 for the first one, 2 and -2. My y-intercept, notice that there's no constant value, so that would also be 0. And then when we do the end behavior as x not y, as x approaches negative infinity, as x approaches infinity. So when I'm looking at my leading term, I have -2, and then if I plug in a negative, that would be a negative cubed. 3 negatives is a negative, times a -2 is a positive, so that means y approaches infinity. Then when I plug in a positive, 3 positives is a positive, times a negative is a negative, so y approaches negative infinity. Then when I graph it, I have 0, -2, 2. When I go to the left, I go up. When I go to the right, I go down. And then what I do is follow the curve. Okay, let's look at our last one. We're going to use synthetic division. It's all the factors of 3, so 1 and 3, divided by all the factors of 2, which is 1 and 2. So that means we have plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. Coefficients are 2, 5, -5, -5, and 3. If I look at this, I see that 1 goes into it. So that's 2, 7. 1 times 7 is 7. 2. 2 is -3. And that gives us a 0. This one right here, I'm going to go for a half. So that's 2, which is 1. 8, which is 4. 6, which is 3. Now I see that all of them are divisible by 2, so I'm going to divide it by 2, and I get x squared plus 4x plus 3, which factors as x plus 3 and x plus 1. So my x values are -3, -1, and then I have the 1/2 and the 1. My y-intercept, when I'm looking at this, my constant value is 3, so that would be y equals 3. As x approaches negative infinity, as x approaches infinity. When I plug in a negative infinity, 4 negatives is a positive. When I plug in a positive, 4 positives is also a positive. So now when I graph this, I have -3, I have -1, I have 1/2 and 1. As it goes to the left, it goes up. As it goes to the right, it goes up. My y-intercept is at 3. So I go down, and then up.